Okay, so you guys should have your note paper on simulations. So we talked a little about simulations yesterday. We talked about doing simulations like by rolling a die or flipping a coin or doing some of those things. Today we're going to look at how can we use a random number table to do a simulation. So just like any of those chance outcomes that we would come up with rolling a dice or flipping a coin and those types of things, this describes random outcomes. Okay? We just have to assign the outcomes to values in the table. So just like what we did when we were selecting samples using a random number table, we can do the same type of thing with this. So you just have to decide how would you assign the outcomes to the values on the table. So for instance, for A, it says we want to simulate flipping coins. So we need to decide how would we assign the values in a random number table. To simulate flipping a coin. So whenever you have a 50-50 chance of something happening, you have lots of ways to divide this up. You just need, first of all, you want to use as few digits as possible. So here we should be able to use one-digit numbers. Okay? So we want to use one-digit numbers to represent flipping a coin. So we just need half of the one-digit numbers to represent heads and half tails. You can divide it up however you want to. You can just pick 5 numbers. Go, all right, I want 1, 4, 7, 8, and 9. Those are the ones I want to use. You can do whatever you want as long as you can keep track of it. Okay? You can say all the even numbers represent heads and the odd numbers represent tails. You can do 0 through 4 is heads, 5 through 9 are tails. However you want to do it, you just want half the numbers to represent each outcome. Okay? So for this one, you can go let 0 through 4 be heads, and 5 through 9 tails. Or you could do let even numbers be heads and odd numbers be tails. There are lots of ways you can do this. As long as you keep track of what you're doing and what each one represents, you're okay. All right, there's not like a perfect way to do it where this one is the right way and everything else is wrong. It's up to you. You have options. You just want to make sure there's an equal chance of either outcome. For rolling a die, okay, if we were going to roll dice, how many different outcomes are possible in a standard die? 6, okay? So we need to each outcome to have a 1 in 6 chance of happening. Okay? So could we use one-digit numbers? There are more than 6 one-digit numbers, but we can ignore values. Okay, so you can say that the numbers 1 through 6 represent that value on the die, and just ignore 0 and 7 through 9. Just ignore those. Keep only the ones that fit what we want. That's valid. You can do that. Okay. So remember, you don't have to assign a value to every possible number in our random number table, but you have to say you're ignoring the ones that we're not going to use. Okay? So here, you may want to say 1 through 6 equal that value on the die, and then ignore 0 and 3739. So if you have more digits than you need, you can ignore stuff. Okay, so don't forget about that ability. So you want to use as few digits as possible, and just remember you can ignore things. On part C, we're talking about M&Ms. They come in a variety of colors according to the Mars Corporation, which makes the M&Ms. The color distribution is 24% blue, 14% brown, 16% green, 20% orange, 13% red, and 14% yellow. How would you assign the digits of a random number table to indicate the color of each individual M&M? So is it possible to use one-digit numbers here? So the thing, these up here, we had a 50-50 chance. We can do half and half. Here we just needed 6 different values. We could do that. Here we need something to represent 24%, 14%, 16%. These are not going to be able to be represented by one-digit numbers. Now 20%, we could show that with one-digit numbers, but these other ones, we can't. So if everything was like 20%, 20%, 30%, then we could do that. But since we have things that don't end in 0, basically, then we cannot represent those with one-digit numbers. So we're going to have to use 2 digits. Okay? The thing when you're doing 2-digit numbers is don't forget about 0, 0, because people forget to assign that to a value. Okay? So when I do these, I usually start with 0, 0 so I don't forget about it. So we'll say let 0, 0 through 23 be blue. So if there's 24% blue, and I'm using 0, 0, that takes one of the numbers, so I just go up to 23. Then I need 14% brown, so I'm just going to go from 24 up to 37. And that's going to be the brown. And then I'll go from 38 up to 53 for the green. And 54. So 54 to 73 is the orange. And 74 to 86 is red. And 87 to 99 is yellow. So we've accounted for every possible 2-digit number, and we have values that correspond to the percentage that they should represent. So it gives you some more instructions down here. You want to make sure you include each of these every time you're writing up a simulation. You want to make sure that you talk about what each digit represents. If you're using a random number table, assign each digit to each possible outcome. Okay, so you need to cover all of the digits and you need to cover all the possible outcomes in the correct proportion. If you are ignoring digits, make sure you mention that. You want to do a step-by-step process to follow a complete single trial. If there's something that you are doing, that you are writing down, that you are marking in some way, you need to write that into your process. Because when somebody else just reads your instructions and does what you did, their paper should look just like yours. Okay, so they should be doing all the same things. When you stop one trial and start another, describe how you know that's time to stop this one and a new trial starts. So go until something happens. And then what variable are you recording? What are you counting for each thing? It's going to tell you that in the problem, but you need to state it in your instructions. And then how many times should you repeat the process? The ones that we're doing today are going to tell you how many times to repeat the process. So you're going to put that in your instructions. Okay, so let's do one of these together. So problem number 1 says a person with type O positive blood can receive blood from any other type O donor. About 44% of the U.S. population has type O blood. At a blood drive, you want to know the average number of potential donors you can expect to examine in order to get 3 units of type O blood. They want us to do 10 trials. So we're going to describe our step-by-step process. So here we're using a random number table, so I'm going to list that as my first instruction. So use a random number table. I'm just going to put RNT because that's commonly assumed. Random number table. How many digits will I need to represent 44%? Yeah. So I'm going to need 2-digit numbers to show 44%. So I'm going to tell them. I'm taking 2 digits at a time. Now I need to assign the 2-digit numbers to an outcome. So I need 44% to be type O blood. So which values do we want to use for that? I like it. So 0 to 43 is type O blood. And we're not really concerned about what blood type the others are, it's just they're not type O. So we're going to let all of the other numbers, 44 through 99, will be not type O blood. We're just looking for, are they type O or are they not? So if the donor is type O, I'm going to have to circle that 2-digit number just to keep track of how many of these we have. So I'm going to say circle the 2-digit number. So that's how I'm going to be able to track how many of those I have. And I want to know what is the average number I need to examine in order to get 3 units of type O1, O blood. So I want to go until I have 3 numbers circled. So that's going to be my stopping point. So continue until 3 numbers are circled. So that's how I know I've ended a trial, because we want to know how many does it take to get 3 donors that are type O. So now I need to think about, what am I recording? For each trial, what am I concerned about? And I want to know, how many did it take, how many donors did I have to go through to get those 3? So I'm going to count and record. The number of donors in that trial. And here they want us to do 10 trials, so I'm going to say repeat for 10 trials. okay with instructions? Makes sense. So now we're just going to come down here to our random number table and we're going to follow those instructions. So I'm going to go to a 2-digit number, 42. That's a type O, so I'm going to circle it. Then I get 83. That's not type O, but then I have 19. Type O. 51 is not, 13 is. So now I have 3 numbers circled, so I'm going to draw a line showing that's the end of the trial. And then I count how many people. So there's 1, 2, 3, 4, 5 2-digit numbers in that trial. So down here where it says T1 for trial 1, I have 5. So there's 5 2-digit numbers to get to 3 that are type O. So for trial 2, I have 43. That one barely made it. 51, and 14, and 20. So this time there were only 4. For trial 3, I have 82, and 15, 14, 3. So that one also has 4. $47, $33, $68, $7, $92, $93, and 4. So after you've gone through your table and you've recorded all this, you want to go back and make sure, did I do anything that I didn't describe? Is there anything that I marked or did where I didn't put it in my description? If there is, you need to go back and add it. Okay? So then it gives you this conclusion statement here. Based on my simulation of 10 trials, I estimate it would take how many donors on average to find 3 type O blood donors. So we just need to add up all these numbers and divide by 10. Have you already done that?
So it's okay to 04 twice?
Yeah. Because we're not selecting people where that 04 represents a specific person. We're just saying that represents someone with type O blood.
Okay.
Yeah. So we're saying, on average, we have to check about 6.7 people to find 3 that have type O blood. So the advantage of doing these simulations is we can simulate checking a lot of people's blood in a short amount of time where it takes us a little time if we were actually carrying this out. If we actually had to draw blood on each person and do the blood typing and get these results, and all, that takes a lot of time. This is a lot quicker, okay? So that's the advantage of simulations, is we can get some information without having to actually carry out the experiment. Questions on this? So I gave you over here problem 2. I want you guys to work through this one and make sure you've got the process down. And then in your folder, you have your simulations task. This, you'll notice, is due next Tuesday, so you have a week from today to get this done. You are going to create basically one of these scenarios. Okay? You can make up whatever you want to simulate. You just need to make sure you include all the information, just like you have in your problems. So you're going to describe your scenario here, give your step-by-step description of how you're going to write your simulation. So that's what we did right here with our description here. On the back, I gave you a random number table that you can use to run your simulation, and then record your data and give a conclusion. Okay? So you're going to create your situation. Basically, you are writing a problem about simulation, and then you're solving it. Okay? This will count as your quiz grade for simulation. So basically, you get a take-home quiz over simulations where you get to make up the problem. So if you have questions, notice this is due on Tuesday after the break, so that means you need to have worked on it. So if you have questions on Monday, you have Monday to ask questions before you turn it in the next day. So don't wait until Monday night and try to get it all done, and then you get confused and you don't know how to do something, and now you can't ask questions. Okay, so do it before then. Any questions at this point? Okay, I'll let you guys work on problem 2. If you want to check yours against my answer, then it'll be up here if you want to do that to make sure you're getting this right. Yes.